Hi, everyone.
Hello, this is Zaki. Welcome to the first Cosmos IBC webinar.
So maybe we'll just give it a few more minutes.
I was going to figure out how to share my screen too.
Okay, cool.
Do you know?
It should be.
See a
Do you have a
button.
button?
No, that makes me disappear. You might have to give me presenting.
Yeah, let me do that. Make presenter. Cool.
Yep.
Good. So we're recording. All right. Yeah, and so just a bit of background. Most of you probably know Zaki. But just to give you a bit of background, as we work our way up to launch, we think one of the topics that's like very important to talk about next is IBC. So we're doing a series this year that can range from more like business and development to rather technical. So this is the first one with Zaki, and then we'll get into another one with Chris Goes next that's a little bit more on the technical side for a presentation he did at Zero Knowledge Summit. And then we'll start bringing in some projects that are using IBC or considering using IBC and get their input. And then if you guys have questions, just in case you're not familiar with this, it's basically using this, and we want to get to live streaming, but this makes it really easy for people to put questions in and then us address them. So put questions in the question tab if you have them. We've got some questions we kind of came up with. And Zaki, I'll hand it over to you to take it away.
Yeah, so let's just contextualize where we are in the process. So of realizing the vision of Cosmos. So we have this launch of a blockchain coming up, which will be the creation of atoms and the creation of the first blockchain that is intended to serve as a hub in the Cosmos network. And obviously that's a major milestone, but in many ways that is about getting to the beginning of a journey that it's really about getting up to the beginning of the vision that Jay, Ethan, and I had back in the summer of 2016, where basically what happened, what we realized is that there's a fundamentally different systems architecture that Ethereum than what Ethereum was building. There was a fundamentally different systems architecture than the world computer, where instead of having a world computer, you had interconnected secure computers, and the sort of secure computers that operate as sort of financial engines. And if we could interconnect all those secure computers, it would be like a global computational fabric that would provide all of the applications that we've ever considered for blockchains, but at the scale of sort of the global economy. So that was sort of the vision, and like, what did we view as the building blocks to that vision? So the first building block was Tendermint, or generically a BFT consensus engine. So we think that I've often thought that the limitations of proof of work meant that you basically, proof of work is hard to. One of the biggest challenges of proof of work is not just is it hugely energy consuming, difficult to find fast throughput, but it also means that the supply of secure blockchain computation is very small. There's really only room in the world for maybe a small number of secure BFT computers that are powered by proof of work. Secure blockchains powered by proof of work. So we needed to get to a new consensus engine that would get us to thousands, tens of thousands, millions of blockchains. And so the vision so we needed to go to deliver that piece. So Jay's been working Jay's been working on Tendermint since 2014. It was getting closer and closer to being what we've seen over this last year actually really like live up to the dream. The dream was that this last 40 years of computer science research could actually be translated into engineering that would allow ad hoc groups of strangers to maintain secure blockchains together. And we've seen that in the testnets. And so that vision is largely sort of reached at least MVP. Obviously there's a long way to, like, there's just so much potential at just the consensus layer, and that it will continue to be improved on for the next decade or more. But really we kind of crossed that barrier. The second barrier was proof of stake. And the idea of running these blockchains in a sort of consortium setting was just profoundly unappealing. I can't, like, the way you get to a world where there are thousands of blockchains is you have total open entry into the blockchain. So you get to you want blockchains that people can join, people can form sort of ad hoc communities around. You can do token generation events that create the pool of people who will run these blockchains, economically incentivize them to continue to do so. So that piece needed to be. So essentially what we've done over the last 2 years is take Tendermint and get it to the level where strangers over the internet can safely run it. Take proof of stake and get it to the level of maturity that the operators of a Tendermint blockchain are economically incentivized to do so, and you can then spin up these blockchains, with the same level of ease as people have been issuing, ERC20 tokens over the last couple of years. So we're done. These things exist. The hub will be a milestone of bringing this technology into a production. But based on testnets, game of stakes, our confidence in this process is just incredibly high. So now the question becomes, okay, so now we get to the beginning, basically, and we get to the beginning of starting to think about how these blockchains will be tied together. And this is what IBC is. IBC is the idea that there are natural separate communities of blockchain. It's astounding to me, given how completely uncoordinated we were with the Binance announcement, how well timed it was for kind of where we are in the maturity of this product and this technology. The Binance is a community. There are BNB token holders. They're interested in running a decentralized exchange. They're interested in figuring out their own crypto economics, and Cosmos is the toolkit for them to do that. And the hub validators and atom holders are another community, and they have a different set of interests, and they're going to do different things. And then we're going to bind these things together over the course of the next couple of years through the IBC protocol. So what is IBC? So IBC has a couple of pieces, so the other thing that I will sort of fully admit is that while virtually nothing about our vision of IBC has changed since we initially came up with the idea almost 2 years ago, actually almost two and a half years ago, almost 3 years ago, the very little of it has been written down, and that's going to be the first step to deploying it as practical engineering on the chain, on the network. This is the first piece of it, which is sort of writing down the spec. But like, I want to walk through a little bit on the history and the origin of these ideas. So I think a lot of people are familiar with sharding. They're the Ethereum 2.0 vision. I would call Polkadot basically, at least in its its nascent form, very similar. The basic idea. So sharding has some things to do, some relationship with IBC, which is there are many chains, and those chains can send data back and forth to each other. The differences between IBC and sharding really come down to the security model. And I've talked about this in some other settings, but the security model is really the key that unlocks the potential of IBC. Sharding is about inter-blockchain communication where every blockchain has the same security. But back in 2015, 2016, I was going through the history of blockchains, or of smart contracts, this technology, and I came across this very 90s website, erights.org. Well, I mean, I was Tony, who is my co-founder on Inclusion, and had been talking about object capabilities and e-rights for a really long time. I was sort of familiar with the ideas, and I really sat down and I'm like, I'm going to read all of this website. And what's really cool about it is it's not smart contracts from the 90s, but there are these ideas here about the electronic rights transfer protocol, capability-based financial instruments. And what I realized comes out of this website is the ability for blockchain applications, for applications to be composed together across separate sovereign computers, because this whole protocol did not envision anything like sharding, that you could have separate sovereign computers connected to each other, composed together, and with a security model that allowed individual chains to fail, individual blockchains to fail. And that really fits incredibly well with the Tendermint vision, which makes it simple and easy to spin up a blockchain, and both simple and easy to spin up a blockchain, but also lets those blockchains be very independent of each other. So erights.org, and the founder, the people who did this work are the founders of the smart contract company Agoric, and that's sort of the relationship between these things. But Cosmos was inspired by their work from 30 years ago, or 20 years ago. So this history of what IBC is, how its security model works, and the basic idea that the way I think about it is if you have sovereignty between blockchains, it's hard to tell the difference between malicious behavior and an upgrade. An upgrade can change the rules of the system. And so this is the sort of difference between the sovereign model and the sharded shared security model. In the sovereign model, every blockchain can upgrade itself, can change the rules under which it operates in any way that the community that is involved in running that blockchain wants. And if you create through IBC a mechanism of composability between them, that composability has to tolerate the possibility that the rules change. And so that's really our fundamental goal with IBC, which is to create this protocol of blockchain interoperability, where any of the blockchains that are in the system can change the rules in which they operate. And as long as they continue to follow the protocol allows compositionality and also limits the ability of any blockchain who changes its rules to cause harm. So that's sort of big picture what we're doing with IBC. So let's talk about this a little. Let's break this down a little bit more and give you some more concrete explanations of why okay, let's like roadmap out now. Well, we'll do two things. I want to talk a little bit about like quick use case stories about IBC, and I also want to talk a little bit about the talk about use case stories, and then I'm going to talk a little bit about sort of the implementation roadmap, and then we can talk a little. We can do question and answer. So the and you know everything about this, like e-rights, how the protocol is going to get implemented in the Cosmos SDK, how to use this, how to use the protocol if you're not a Cosmos SDK user. Like these are all going to be topics for future webinars and future documentation and future conversations and panels. You know, I think like IBC is such a fundamentally new primitive that we're bringing to the blockchain. It's not actually, my estimation is it's going to be less technically complex than proof of stake was, but the conceptual framework is going to be new and interesting. It's going to take quite some time to educate the community about. But I will also say that from a development point of view, you know, our focus is starting to shift. You know, now that we're sort of at the end of the road on proof of stake, sort of the next protocol developments are going to be MVP IBC. Okay, so let's talk a little bit about applications. About like what kinds of applications does IBC enable? So one application that I think so by far without a doubt, the other thing that should be well understood is, at least when I conceived of what Cosmos was and how Cosmos was going to work and what problems it was going to solve, the basic set of ideas of like what was the use case for this is what we've seen come into existence with open finance. And I have been incredibly blown away by the kinds of open finance primitives that have been successful in Ethereum, like the hundreds of millions of dollars in the Maker DAI collateral contract is just like incredibly impressive to me. It's a huge validation, but like every one of these open finance systems have something on the order of a couple of thousand users, and you know, it was obvious to me back in 2016 that if any of this stuff took off, it would run into real limitations in terms of scaling and composability. It was also unclear to me whether or not anyone could write EV software on the Ethereum virtual machine that was sufficiently reliable to do this stuff. And it's been kind of mind blowing that, and it like speaks to just like heroic levels of effort on the parts of teams to get software written on the Ethereum virtual machine to this level of reliability. So what does an application on IBC really look like? So I think like what is I want to use Maker as an example, and the Maker stablecoin as an example, because I think it composes financial primitives in ways that are really easy to understand, or at least, so if you're not familiar with Maker, sort of the basic idea of Maker is you take some collateral instrument on Ethereum, and in the current form of Maker, that collateral is Ether. There's a price oracle that says what the current value of Ether in dollars is. And in order to issue new DAI, which is a stable coin that is targeted to be worth approximately $1 and retain stable value, you lock up into what is called a collateralized debt position, a CDP, 150% of the value in Ether of your current amount of Ether, and then there is some liquidation price at which point the CDP will be liquidated if Ether falls below something like I don't remember what the collateralization ratio is, but if it falls below a certain ratio, according to the price oracle, it gets liquidated. So how does this work on, how would this work on Cosmos, in Cosmos with IBC? You would have a zone, a Cosmos zone connected to the hub that would spin up. It would be able to, so on that, there would be a set of transactions that would be defined in the Cosmos SDK for creating CDPs, and there would be an IBC contract. So the IBC contract would, or so over the IBC channel, you would get, over the IBC channel, you would get Ether, or you could get Ether, Bitcoin, atoms, photons, whatever other tokens that exist in the Cosmos ecosystem would be able to flow into this contract. There would be some sort of price oracle that would be telling the maker blockchain what the different price ratios would be. People would then be able to lock up funds, and they would get issued sort of Cosmos DAI, and then that Cosmos DAI would flow back over the IBC channel, and you can use it for buying coffee, music, whatever. Why is everyone talking? Okay. So those are the missing, those are the pieces. So you have a Cosmos, you have the hub, you have your maker chain, you have collateral assets flowing into your maker chain putting those assets in CDPs, and holding that collateral on that chain. You might have some sort of DEX on that chain itself for liquidating those CDPs when you need to, and then you have stable coins flowing out into the Cosmos ecosystem. So that's the sort of conceptual model of what IBC is there to enable. So let's think a little bit about this from a security point of view. So what can go wrong? And what can go wrong is what happens if that maker chain is taken over by evil validators, and those evil validators no longer want to run the system. They want to exploit the system to make as much money as possible. So what are they going to want to do? They're going to want to steal all of the collateral for themselves, and that collateral is no longer going to back your stable coins. So the core idea of IBC and how IBC allows us to compose these blockchain applications is that that if you look at if you have this application, everywhere in Cosmos where the new token that has been issued by this stable coin chain gets issued, you're going to see the name of the stable coin chain and then the asset. So it would be like Cosmos Maker Chain DAI. If the chain turns evil, the only people who are affected by it are the people who were the owners of that collateral, who locked up their Bitcoin or their atoms or whatever on the collateral. Those validators came in and stole their upgraded the chain to a new consensus algorithm, which basically gives them all of the collateral. And then the people who are holding the Cosmos DAI. But people who are not interacting with this ecosystem are unaffected and do not care. And so what this does is it creates sort of an expansive market for security. People are going to, blockchains are going to have the perception of whether or not assets issued by a blockchain that are moving over Cosmos are going to come down to whether or not the market thinks that the validator set for that blockchain is secure, whether or not they think the proof of stake asset that secures it is secure. That's and that's the basic vision of what IBC enables. Okay, so having explained all that, let's talk a little bit about the implementation roadmap. So there's basically and we're gonna probably open up a GitHub issue to like sort of track the pieces of this. But there's basically a bunch of pieces of IBC that are gonna have to be spec'd out. Each of these specs are relatively small. So the first piece is gonna be the connection and channel versioning scheme to enable upgradability. We expect that there will be many versions of IBC that come into existence. There's going to be the MVP IBC mechanism, and then we expect as the ecosystem expands, other versions of IBCs to prop up and propagate between and ecosystems crop up around them. So the next thing we need to do is take the Tendermint light client implementation that currently is used for applications like Gaia CLI, the CLI that interfaces with the full node and verifies light client proofs. And we're gonna have to just port that in a simplified version into the SDK. So we're gonna have a simplified Tendermint light client in the SDK. We're gonna be able to reuse some of the code from Tendermint today, but it has to store block headers in the IAVL tree, in the multi-store, needs to be able to do things like that. The next piece is going to be a naming scheme for a name scheme for chains. One of the key things that we have to figure out, or one of the key security assumptions is there doesn't need to be global names for chains. The hub can maintain its own list of names for chains for its connections, but it would certainly be handy if there was a global names list for chains. Probably not going to be in the first version of IBC. Then we need to figure out the chain registration process, which is what is the data and the transaction that you need to send to create a new IBC chain, a new IBC connection. It's a validator set, a root of trust, and maybe some other data. But that's going to be it. Potentially, it would make sense to run some sort of name service, especially for the UI layer, so that it's likely that chain names sort of natively won't be human readable, and there'll be some sort of name service application that says, oh, chain 137 is actually is named Cosmos chain, but is named the maker chain or connection, and connection 584 to the hub is to the Dex chain, etc. But that may be a service run on the hub. It may be a separate chain. A little bit TBD exactly what's going to go in there. There's going to be the packet spec, which is how do you what should be in a packet when it says I'm sending you some tokens that came from another chain. What should be in a packet when you're creating a token that you created? Conceptually pretty simple. I'm not expecting any of this stuff to be too complicated. The channel and queue spec, which largely already exists. The fraud proof system. So you need to be able to submit fraud proofs to the hub, or from the hub. Basically, you need to be able to submit fraud proofs on both sides of the channel, which is basically if there was ever a double sign or a validator split, etc., a channel needs to shut down automatically in that case. And then the last piece is going to be we expect chains to both halt in an unplanned manner, like what we see in the Cosmos in Gaia when there's an invariant break and it halts. You might see planned upgrades, and so we need to have a recovery mechanism by which the validators can sign some piece of data submitted to the channel and be like, okay, the chain ID's changed, we're back to 0 height, but you should persist all the assets, and we're expecting all of the balances to on the other side of this channel to stay. And so this is a couple of months of implementation work, and so that's what we're expecting to work on next. But sort of once this vision's in place, then even more exciting stuff gets built on top of it, future versions of IBC that allow cross-chain smart contracts, function calls across chains. All of that stuff can be built on top of these basic primitives. And so that's the goal, and we're gonna dig in more deeply as that goes on. So I've been talking for about half an hour, just sort of ranting at you. Thank you guys, the 19 people who showed up to listen. But I'd love to answer questions. I expect a lot of stuff is unclear, but this is going to be like a big part of getting IBC off the ground is not just going to be like writing a bunch of code, but also like mind dumping a bunch of ideas that have only really existed in like Jay, Ethan, Chris, Sunny's heads for several years. But we're finally like in a position to bring these ideas to life.
So Zaki, just a few things. Maybe if people want to ask questions, we came up with a few questions. Got some of the developers in full node to come up with some questions about IBC, but maybe if you would also explain, like you kind of gave the roadmap and implementation from our side, but for people building dApps or people building on Cosmos, what kind of implementation would that mean from their end? Like based on our roadmap and that, like could you go into more detail on their side?
Yeah, so if you are building on top of the Cosmos SDK, you're going to have a really simple time adopting IBC. So today, let's say you build a decentralized exchange, a prediction market, anything you imagine building on top of IBC, a DEX like Binance is building, etc. You're just going to be able to upgrade your SDK version, pull in the IBC changes as they start to land, and then integrate IBC into your application using the same sort of module-to-module composability that we've already developed inside of the SDK. If you're building a Tendermint application that isn't using the SDK, you're probably going to have to implement a lot more of the spec yourself. We are certainly thinking about having a second non-SDK implementation of the spec. It's definitely been floated, the idea of implementing it for Substrate as a possibility. That might be something that would be fun and cool to do. And then future versions of IBC will most likely support alternatives to Tendermint consensus. But in the early days, at least for what I can imagine sort of shipping in this next year, our target is to support chains that support Tendermint.
Okay, but like even if projects though are not using Tendermint and aren't using Cosmos, they can still use IBC to connect, right, to the Cosmos network.
Eventually,
right? In theory. Okay.
Like that's like maybe like a 2020, 2021 kind of time frame for that. Whereas like if you're building Cosmos SDK application, it's going to be like a drop-in thing to support IBC. If you're building a Tendermint application, it's probably on the order of a couple of thousand lines of code. If you're kind of completely outside of this ecosystem, you want to adopt IBC. There are certainly ideas, but like basically what that involves is sort of transforming the building blocks of IBC, which is verifying consensus proofs and fraud proofs into sort of generic functions that when a connection gets instantiated, you like drop a bunch of WebAssembly into it. But that's like making everything super dynamic is a great design goal and something we will eventually do, but not sort of the right way to do the first version of this.
And just in terms of timing, like once we get it done on our end and it's available for upgrade on a Cosmos SDK implementation, like how much time would someone have to consider for that? Would it just be like a week, a day? I mean, how long would it take them once all of this is kind of done on our end?
I suspect it's probably if what you are doing is using the Cosmos SDK bank module and you are using the Cosmos SDK, it will simply probably be an upgrade of the Cosmos SDK, and you'll probably get a sense though. So like Cosmos SDK upgrades have been extremely breaking over the last couple of releases. We're expecting that to calm down and like there to be less just churn on the Cosmos SDK relatively soon. But so if you kind of track like how hard it was to adopt the next kind of post-launch releases, it's probably going to be on that same level of difficulty.
Okay. We have one question, it looks like, from someone listening, and then we can maybe run through some of the questions that, like, just talking with people who are familiar with Cosmos but were curious about IBC, came up with. It looks like the question is, are validators elected and rewarded by each zone?
Yes. Every zone has its own validator set, crypto economic model for rewarding validators. And that's part of what makes IBC interesting and distinct from what's going on, the way sharded blockchains think about interchain communication, which is you have your own validator set, and those validator set controls the blockchain independently, but can exchange assets with exchange things of value between chains.
I guess one question would be also is like we came up with like how tied to Cosmos is it? Obviously, it's easier. You mentioned about if you're using Cosmos SDK, but how tied to Cosmos is it? Can people implement IBC without Cosmos or Tendermint?
So the best way to understand how tied to Cosmos IBC is it's really, I mean, it comes down to the question of what is Cosmos. Cosmos is really is a systems architecture. It's an architecture of intercommunicating BFT systems. Right now, there's really not a lot of BFT blockchains out there that like sort of employ classical Byzantine fault tolerant algorithms, but like simply vast amounts of money have been raised and are being spent trying to instantiate other BFT blockchains. So we anticipate that like any of those blockchains will very easily be able to interoperate with Cosmos and just become part of Cosmos. And then there's always the peg zone concept as well. But there's always going to be a pretty significant, peg zones are always going to have their own sort of complicated crypto economic model by which an asset is like virtualized into Cosmos, whereas anything that's BFT will just natively be able to support Cosmos. And so, by being like largely first to market with all of this stuff, I anticipate that there will be a pretty high likelihood of convergence around like everything supporting at least this mechanism of interoperability.
Okay, looks like I'm pretty choppy question, but function calls across chains, aka smart contract execution across zones, and similar to Polkadot. I don't know if you see this question.
Polkadot is sharding, and so they operate on. So their version of smart contract execution across zones is going to be sort of driven by the sharding related based security model, where you assume that every chain in the ecosystem has consistent security, and this is sort of where why we've shied away from direct contract invocation across chains. But if you actually look at what Agoric has been working on, they have a version of smart contract invocation across chains that is compatible with the Cosmos security model. So it clearly can be done. In fact, Agoric's made an enormous amount of progress. The team at Cadena has also kind of their own vision of this. And honestly, like, I'm not a programming language implementer, so it's sort of been outside of my, I'm a cryptography and distributed systems person. And sort of outside of my skill set to kind of conceptualize a system like this. But I can look at the work of others and see that it can be done. And so I expect that, like, given that it can be done, it will be done in the Cosmos ecosystem. And that's why we wanted to get, like, the very first thing that we wanted to get into into the spec and into the implementation is a versioning system. So if the first version of Cosmos only sends like Oracle data events and tokens and NFTs across blockchains, or at least the ownership rights to those tokens and NFTs, a future version, a company like Agoric could immediately spin up IBC v2 or IBC v3 and start shipping their version of intercontract composability.
Can you connect and disconnect with IBC? So if it's inter-blockchain communication and you are connecting various blockchains, will there be a way to disconnect? I guess the question kind of comes from like, what risks do you have by connecting to another blockchain?
We have some ideas. So there are some interesting ideas of like what you could do here.
I mean, from a security standpoint too, no?
Yeah. It's actually probably not that hard to enable connecting and disconnecting. The big question is can you enable disconnection without like a heavyweight governance intervention to sort of figure out what to do about those assets if they've been disposed of. And basically you might want to have a thing which is like if a connection disconnects and like doesn't reconnect in 6 months or something like that, all of the assets just go into the hub community pool to be managed there. We could do something like that. That's really the only change with disconnecting. Like it's an asynchronous system, but like if you haven't received a packet from that blockchain in 6 months, you probably just want to assume that blockchain has disconnected from you.
Okay. As someone who wants to build gaming dApps, what are the benefits of using the Cosmos SDK?
What are the benefits of using the Cosmos SDK for building gaming dApps? So we have a partner, Loom, who is a user of Tendermint and some of the pieces of the Cosmos SDK, and they've built a gaming specific implementation of an SDK, which seems great, and they're super excited about interoperating with Cosmos, but I think the Cosmos SDK could also be a pretty great application could be adapted pretty easily to serve the needs of gamers. The main advantage of using the Cosmos SDK is you're just able to deliver a much better gaming experience than if you've ever looked at Loom's applications. They look like modern multiplayer video games. They don't look like they're not as constrained as like the set of blockchain applications that run on Ethereum or EOS. Essentially the Tendermint and Cosmos backend supports a sort of transaction throughput that is very similar to like another distributed database, and you would be able to sort of deliver kind of a rich user interface from that. So I think you're going to see a lot of gaming applications on Cosmos. And then the reason to support IBC is to sort of bring it back is, you want to be a game developer, but why are you building on a blockchain? Because you want digital scarcity. You want credible, when your blockchain says, there are only 5 magic swords, you want there to be a lot of credibility that there are only ever going to be 5 of those magic swords, and that and then you want liquidity around those magic swords. You want people to buy and sell them. And potentially you also want to be able to use digital assets that are foreign to your game to come over as a way of sort of inviting other gaming communities into your new application. Those are the reasons why you want to use a blockchain. And for at least 2 of 3 of them, IBC is a really compelling solution because, you start up a new game, you're not going to have a decentralized exchange with a lot of liquidity on it. You're not even going to have access to like, NFT exchanges with a lot of liquidity on it on your own blockchain. But if you connect to IBC, we expect that all of the big NFT exchanges, decentralized exchanges, will very quickly end up supporting assets that come in over IBC, and will be able to you'll be able to your users, your players will be able to buy and sell assets on your gaming platform pretty easily.
Yep, and it's a pretty good way to break a little bit the market, right? That's already quite established with some large gaming studios.
Yep.
Quick to summarize this one, are you going to be working with other projects and let other teams expand IBC, particularly IrisNet? And just on the IrisNet, they will be part of this meetup series. We'll invite them to come and talk about IBC as well. But just, I guess, Zaki, do you see other teams expanding on IBC and implementing your version?
Yes,
Our version,
absolutely. The IBC that I've described today is very much like sort of the base layer. It's sort of a very minimal description of capabilities. It's something that's probably pretty easy for, like, hopefully the market can reason about their security pretty easily. But like IBC is a permissionless system. It is an utterly permissionless system. I think one of the technical trade-offs that we probably we haven't finally decided between is, should the first implementation of IBC just be exchanging Iris tokens and atoms between Iris Hub and the Cosmos Hub? You can send atoms to Iris. Iris users can send Iris to the hub. That would, in some senses, like, that simplifies the spec quite a bit, like, and gets us an MVP of the thing. But it also isn't super excited because it's not permissionless. So I've so far been advocating in favor of doing a little bit of the extra work so that the first version of IBC, though, like what I just described, which is like a chain-to-chain fixed connection, we will definitely manifest in a testnet. But probably when we upgrade the hub to support IBC, I'd like to support it in a permissionless setting where any chain can just roll up, submit a transaction to the hub, and get an IBC connection.
Cool. Difference? Could you quickly explain difference between e-rights and the earlier IBC spec implementation? And basically, is it worth the additional work from the e-rights?
So the original IBC spec was inspired by e-rights, but in massively simplified version that only sort of contemplates fungible and non-fungible assets and a single right, which is the right to transfer or own that asset. E-rights is then an expanded version, which basically encompasses some notion of like a programming language and the ability to specify in that programming language arbitrary rights that can move across blockchains. So it's a natural upgrade. I think that these things will get sequenced out over the next couple of years.
Okay. One of the things you mentioned, like the connection between the different blockchains, but is there any impact when you transfer assets and tokens between one blockchain and another, and a fund either gets maybe corrupted, frozen, becomes inactive? How would that impact the communication between different chains? How would that work exactly?
So basic model of IBC is like once you send funds to a blockchain, it can more or less do arbitrary things with those funds.
Okay.
So it can do the desirable thing, like facilitate decentralized exchange or facilitate using these blockchains and in other kinds of these assets and to collateralize a CDP, etc. It can also do terrible things like just steal all your money. And we are not trying to necessarily prevent that. I think globally preventing that is a super hard problem. It is certainly not something that I think is easily technologically feasible today, unless you have like an EVM style universal virtual machine. And so we're not going to do that. We're gonna preserve sovereignty and independence, but there's going to be potentially more risk to users, and users are going to have to be really careful about what chains they send their assets to.
You also mentioned it's permissionless, but then you mentioned a validator set can be evaluated in order to connect to another chain.
Yes,
So
but that's not the hub job.
Okay.
The hub isn't. Yeah, go ahead.
No, I just was curious, like, will different validator sets work? So like if it's a private validator set, would they be maybe rejected? Like, is it like a permission version?
There's not really a need or a mechanism like planned for rejecting them.
Okay.
I think the security of this, like, it would be basically like we completely screwed up the security model of the system. If something like that, some sort of whitelist of acceptable validator sets is required, we expect that it will be in the economic interests of the operators of hubs to connect to everyone, and so that will probably be
the standard.
Yeah.
Okay. Could Ethereum 2.0 implement IBC to integrate with Cosmos, and what could that implementation look like?
What was the question? Ethereum 2.0?
Yeah. Could Ethereum 2.0 implement IBC?
Yeah, it could. It would be pretty easy to, like, the beacon chain sort of fulfills all of the requirements of an IBC implementing system, and so I anticipate that is something that the Ethereum community might be willing to do. And we've been talking to some of the Ethereum 2.0 implementation teams about IBC support in the beacon chain.
Okay, just a few quick questions. How long before we see zones connecting to Cosmos? So it seems Loom have implemented their version of IBC.
Well, my expectation is I would say probably the first two projects I can see short term connecting to Cosmos are Iris and Loom.
Iris, yeah.
Yeah, and I'm not committing to a timeline here. I think it's something on the order. So test nuts soon, but a mainnet upgrade of the Cosmos Hub and upgrades of both Loom's chain and the Iris chain or something on the order of 3 to 6 months out.
Okay, and then one of the other things you mentioned was fraud proofs.
Yep.
And submitting fraud proofs for both sides of the channel.
Yep.
So will fraud proofs be standardized across blockchains, or will that be something that changes?
We are going to support very simple fraud proofs in the first version of IBC that are basically Tendermint fraud proofs. Basically, like, if the validator set approved different blocks at the same height, with 2/3 signatures on it, or like different validators set hashes on the same block height, that kind of stuff we will use as evidence to shut down a channel. But the future versions of IBC can certainly consider all kinds of more fancy fraud proofs and validity proofs, like using snarks and starks and all kinds of other crazy stuff.
Okay, and then the last question is that we came up with in the sitting around talking about IBC earlier is like we're talking about tokens, right? That you can move from blockchain to blockchain with IBC.
Yeah.
Well, move, but will you be able to do that with? I guess we came up with arbitrary statements. Or will you have to tokenize something in order to do that?
No, So the difference between a statement and a function call is, okay, so there's like a bunch of different fine-grained differences here. So a token is sort of an ownership right, and you want to have when you want to lock that ownership right on one side of the connection and then transfer it to the other side of the connection, either freeze or burn that ownership right on one side of the connection, transfer it to the other side of the connection. And then that ownership right gets instantiated on the other side of the connection, and you want a handshake that sequence of events has been followed. And IBC will support that. It should be pretty easy to also have kind of stateless event sending that is routed over the IBC layer. So if a chain just wants to publish an event, that the outcome of a prediction market or some other a price feed data point or something like that, that also seems like something that would be very easy and very natural to support over IBC. And so events other chains can subscribe to these events and get them over the IBC channel, and then be like, okay, now I know that the price of ETH, the relative price to ETH to Loom tokens is X. And if your state machine wants to use that, it can. So those kinds of statements will be relatively easy to add to IBC. The more complicated stuff is the sort of e-rights ideas, and I'm sure that will come in time.
Okay, great. We're about at the time, and I don't think we have any more questions. Okay, I don't think we have any more questions, but thanks for tuning in, and then we will keep doing this over the next couple of months too. And the next one will be, like I said, with Chris Goes, his Zero Knowledge Summit presentation. That's a much more technical presentation, and we'll exchange between kind of these panel discussions and technical. So yep. Thanks, guys.
This is just the first intro, and with launch coming up, I kind of want it was important to start communicating more broadly about this stuff.
Yes, and suggestions are welcome. Thanks, Zaki.
Thank you.
Thanks.